everyone present here. I extend a heartfelt welcome to you all for Keynote Session 2. Title, Low Cost and Sustainability Foldscope-Based Method for Practical Shape Characterization of Geomaterials and its Effects on Dynamic Shear Modules by Kunjari at IACESD 2023. I request Mrs. Vindhya Ma'am to introduce the keynote speaker to the gathering.
Good morning. It's my immense pleasure to introduce Dr. Kunjari Mog. Dr. Kunjari Mog, an Institute Postdoctoral Fellow at IIT Bombay, holds a PhD in Civil Engineering from the Indian Institute of Science, Bangalore. He is a lifetime member of the Indian Geotechnical Society, a member of the Institutions of Engineers India, the Geotechnical Extreme Events Reconnaissance in the USA, and the Indian Society of Earthquake Technology. Dr. Kunjari has published several journal papers and presented his research at national and international conferences, receiving several awards and grants for his work. He is also involved in extracurricular activities, including serving as the founding chairman of the Inspire to Ignite Drive IID, an NGO that provides mentorship programs and science outreach activities in remote areas of Tripura. So it's it's our privilege to have you here, sir.
Shall I start? Okay, it's good to be here, particularly weather, because I'm coming from Mumbai, and if you get this kind of weather, obviously. How many of you are PhD scholars? Anyone? MTechs? BTechs, right? Okay. Fine. Okay, thank you for the kind introduction, Professor. Ladies and gentlemen, distinguished guest and my mentor, Professor Pinamudi, very good morning. I am Dr. Kunjari Mog, an Institute Postdoctoral Fellow at the Department of Civil Engineering, IIT Bombay. It is an honor and pleasure to be here at the international and as one of the speakers at International Conference on Interdisciplinary Approaches in Civil Engineering for Sustainable Approaches for the Sustainable Development. Today I have the privilege to present on the topic Foldscopic Approach for Particle Shape Characterization of Geomaterials and its effect on dynamic shear modulus. So this research delves into the influence of the dynamic shear modulus of geomaterials employing an affordable and environmental friendly Foldscope approach. Have you heard about any Foldscope earlier? Anyone? On YouTube or somewhere? Okay, fine, then we will see today. So while the concept of sustainability lacks a universally agreed upon definition, however, experts believe that, according to the expert, sustainability is a concept that encompasses environmental, economical, and social aspects. The Foldscope approach that we will be presenting today embodies these three pillars of sustainability. It is cost effective, it is budget of less than 500 rupees. You can see this. Just wants to open this. So this is the Foldscope. You are going to see this. And with a small camera, fixing with mobile, you can take the images of the particles. So I can pass this on to you people so that you can just check. So the cost effective, it is a Foldscope is a less than 500 rupees and it is cost effective, making it economically sustainable. And the materials used in this approach are recyclable, ensuring environmental sustainability. Lastly, its versatility and widespread applicability contributes to its social sustainability. So I believe this work has the potential to revolutionize civil engineering by providing a practical and cost-effective method for analyzing the properties of geomaterials, thereby enabling more efficient and sustainable design practices. I am truly grateful for this remarkable opportunity to share my research and engage in fruitful discussions. with all of you. I hope you will have attentive presence, and I eagerly anticipate the highlighting sessions that is going to be. So to provide a clear framework for today's presentation, let me briefly outline the key points I will cover. Firstly, I will start with the introduction, where I will provide an overview of the importance of the particle shape and the need for a sustainable approach for particle shape characterizations. Next, I will delve into the main body of the presentations, which will divide into two sections, 1 and 2. The first section will discuss the low-cost, sustainable full-scope approach for particle shape analysis of geomaterials. So I will explain in the first part the methodology and showcase the results that we have obtained in our research. The second section will focus on the effect of particle shape on the dynamic shear modulus of geomaterials, in which I will present the highlights, the findings and highlights of the implications of the particle shape in civil engineering applications. So finally, I will conclude the presentation by discussing the potential impacts of the research on sustainable design practices in civil engineering. With this outline in mind, let us now proceed to the introduction. So if you see here, I have shown the particle shapes just to get familiar with that. We all know that the shape is a fundamental property of any objects. So, and its important physical attribute can provide a formation history of the sedimentary particles or the hydrodynamic behavior of the transporting medium it can give. So it has been recognized that particles size and shape has a significant influence on the dynamic soil behavior. So we have a static behavior, we have a dynamic behavior of soil. So whenever some earthquakes or dynamic load happens, then the dynamic behavior, we assume it as dynamic. So the mechanical response or behavioral characteristics of an ensemble granular mass completely depends on this, shear strain properties, the inter particle-to-particle interactions or internal frictions, permeability, the difference between two weight ratios, extreme weight ratio of packing density, compressibility, etc. depends on these shape properties. Now, if you see at the top here, I have given for fine sand, coarse sand, and angular pebbles the angle of repose. You can see here, I don't know whether it's visible backside or not. The angle of repose can differ for fine sand, which is 35 degree, this is for 40 degree, and for angular or gravel, this is 45 degree. That means whenever some kind of a load will be applied on the soil, then based on the shape properties, the particle shape, it will behave. So that is the reason this quantifying these shape properties is essential for soil classification guidelines or behavioral prediction. Now, over a few decades, if we see different methods and techniques have been developed and modified by several authors to investigate the morphology of the soil particles, including hand measurement, then your sieve analysis, which all know in BTech program, BTech studies we know, then your chart comparisons, then Fourier spectral analysis, then digital image analysis we have now. So Chu et al. In 2006 specifically emphasized the inclusion of the importance of particle shape in soil classification guidelines. However, this phase of research has received less attention. Despite its importance being accepted for quite some time, it's remained ignored and not accounted for in soil standard classification guidelines. So comparatively, there has been limited documentation also about particle shape characterization in geotechnical engineering report or civil engineering literature. If we see any geotechnical engineering report which are provided by some construction company or you may not find these particle shape properties. So why? Because this is primarily due to the limited access to high quality particle measurement facilities like scanning electron microscope or optical microscope or sophisticated image scanners. So most of the earlier studies have conducted based on a microscope-based or SEM-based. But SEM on microscope is very expensive, which cannot be affordable by meaning. So this shortcoming can be eliminated using the inexpensive microscope-based paper microscope, which was originally developed by Foldscope et al. By the Stanford University professor led by. And this Foldscope is a sustainable and low cost and sustainable alternatives. I think Foldscope, you can just pass that on, they can see that Foldscope, whatever I have just passed on to you. Now coming to the section 1, which is the particle shape analysis using the Foldscope approach. So to characterize the particle shapes, the first 12 particle images were captured using the Foldscope instrument. Then all the captured images were transferred to the image software. Then digital image processing were carried out, and particle shape parameters such as circularity, roundness, and aspect ratio were determined. Now next, to check the effectiveness of this Foldscope instrument, the same soil samples, whatever shape was determined, the same soil specimens were also, images were taken using SEM, then again it was transferred to the image software, then particle shape were determined, and finally the results between Foldscope and SEM were compared to check the effectiveness of the Foldscope. So the key objectives were obviously the usefulness of the Foldscope instrument, whether it can be used for quantifying particle shape, that is the first objective. Then to investigate how many particles should be sufficient to yield a representative results of a answerable soil mass. How many particles should be adequate? So, and resolution effects. Now for that purpose, 4 different types specimens were considered, and such as here A, B, C, D, and all the test samples fall under the category of SP or colligated set. So the photographic view of SEM and Foldscope is shown, which is left and right side. As previously mentioned, these sand particles were captured using the 2 instruments such as GeoSEM and Foldscope. Then all the images were transferred to the image, and digital image processing were carried out to characterize the particle shape. So if we see, it comes here like this only. If you order from online or something, you can order. So then you have to open, if you open that, you will find this kind of assembly. So the assembly of the Foldscope parts is shown here, which consists of 4 stages. First stage is your lens stage, then sample stage, training guide, and focus rack. Then you will all combine. Then and under the sample preparation, first you have to prepare the sample. Where is the Foldscope now? It is Foldscope where? Okay, yeah, fine. So yeah, fine. Okay. Under the sample preparations, samples were first gently pasted on the sticker of the sample slide. You can see on the top left figure. Then scale slide of 0.5 mm or 0.5 mm or 1 mm can be used depending on the particle size, whether it's a fine sand particle or coarse sand particle. You can change the scale slide, and you can fix that on the bottom of the scale slide. And finally, by panning exercise and focusing the Foldscope magnification range, the images can be taken. So a video clip of image detection of sand particles. I will see whether it's running or not here. Okay, it's not running, probably, fine. So you can fix the Foldscope on that mobile camera can be fixed and take a picture. Now the Foldscopic view of the 4 test samples is presented here. You can see on the left A, B, and C. These figures were taken using the 64 megapixel, this Realme XT camera, and on the right side, this picture is taken using the Redmi 4 megapixel camera. So you can see it is not so clear. But for the analysis, we need to consider the clear images for shape analysis. Now, after capturing the particle images in full scope, the same small particles will be images will be taken using SEM and visual image processing will be carried out. So this is about SEM or Geomaterials image, which is scanning. We call it as scanning electron microscope. So it consists of an electron optical system to produce a fine electron beam. A specimen stage we can see at the bottom. Then secondary electron detector, a computer and display unit. So I'm not going into details of this. Now for sample preparation under scanning electron microscope, first 20 to 30 grams of soil samples is taken and it has to be kept for desiccation for for 1 day, 24 hours. Next, these sand particles are firmly fixed to the specimen mount, which you can see here, metal plate. Specimen has to be fixed there by a conductive double side tab. Here you have to fix that. On that, particle has to be fixed, which is shown here. This slide. Then the specimen surface is coated with a thin metal plate. This is not coated, so this thin metal plate, which is gold coated metal plate, has to be coated here, which is of thickness 10 nanometers, so that the conductivity when the electron beams shoot, so the conductivity gets and we can take the pictures. That is the main reason for conducting for putting the gold material. Finally, the specimen mount is placed to the SEM and we can take the picture or images. Now, SEM view of the 4 test samples. You have seen the Foldscope view, which I have shown earlier. Now, this is the scanning electron microscope, which is about more than 50 lakhs. This instrument costs more than 50 lakhs. However, that Foldscope cost is less than 500 rupees. So you can say, obviously, you will definitely expect the clear picture of this. So ABCD, which is Brahmaputra sand, Tripura surface lithophane sand, which is from the northeast, Mono River belt sand also from the Assam, then Kalpakkam sand, which is from the nuclear power plant site, taken. Now, after capturing the images using Foldscope and SEM, as I was mentioning, all the images were transferred to image software. You can do the image analysis using your Sigma Pro or MATLAB also, if you don't have this image analysis software. Image is an open source Java-based processing and analysis program was developed by Wayne Rasband at the National Institute of Health in 1997. So, in order to perform the image analysis operation, captured images were first loaded to the imager, but calibration has to be done, because whatever in the real, then if you want to convert it to the computer system, then some calibration has to be done, and that should be proper. Then the images were converted into binary images, which is black and white. So for one of the samples I have shown, this is the normal images. Then you have to convert it to binary images. This is for one particular specimen particle. This is for different particles. So it shows the original image and its binary image in the image analysis software. So after that, see the shape descriptors, which is roundness, aspect ratio, roundness, circularity, aspect ratio is defined in image in this fashion. So this aspect ratio is actually major axis or minor axis. We can calculate. Then roundness parameter is defined by this area 4 into area by pi into this major axis, and circularity is defined by 4 pi area by parameter square. So when we have a circularity value of 1, it indicates a perfect circle. As the value approaches to 0, that means it indicates an increasingly elongated shape. So perfect circle is 1, and whenever it approaches to 0, this is a completely elongated shape, but elongated shape kind of So that we have to consider. Now coming to the results and discussions. So while quantifying the particle shape descriptor, a fundamental question arises. What is that? Whether the number of particles, how many number of particles should we take for quantitative analysis? Because there are a lot of particles, like thousands or crores, millions, billions. So how many numbers should be taken for a representative soil mass? That is a fundamental question, right? So in the literature, people have taken the number of particles considered varies from 20 to 260 particles so far. So how many number of particles should be taken for us? That is a question, right? How many particles should be sufficient to yield a representative result? Or is there any effects when we take randomly selecting when we select a randomly particles and do the analysis, whether there will be effect or not? That we have seen first. So in our study, to investigate the influence of selecting a different number of particles on roundness parameters. So there are 3 parameters we have considered: roundness, circularity, and aspect ratio. So we have considered 40, 80, and 120 number of particles. So the roundness parameter result obtained from Foldscope is shown here, and obtained from scanning electron microscope is shown here. So you can see this is the roundness value, this is the number of particles. Now for 4 different type of soil material or sand as shown, you can see at 40 number of particles, 80 number of particles, and 120 number of particles, there is no variation for the roundness value. Same case for SEM also. This is for Foldscope, there is no variation. Same roundness parameter for 40 number, 80 number, or 180 number particles also, there is no much variation. Only a slight difference you can see for Foldscope sand. So that means, okay, this was working fine. Yeah, fine. So similarly, the analysis for aspect ratio is shown on the left for the Foldscope approach, and result from the scanning electron microscope is shown on the right here. As you can see, with the increase of number of particles for this Foldscope and aspect ratio parameter as well as circularity parameter also, there is no much variation. It looks like, it appears that if we take the 80 number of particles, that should be sufficient for particle shape analysis. So it appears that 80 number of particles are adequate to get a consistent result for a poorly graded sands. Now the comparison between the Foldscope and SEM results are shown here. You can see the percentage variation here also. For roundness, aspect ratio is less than 5%. That means you can, the Foldscope result is matching with the SEM results. What is the cost of Foldscope? 500 rupees. It is sustainable. What is the cost of SEM? It is more than 50 lakhs to 1 crore. So definitely you can go with that. We can. Only thing is that in case of circularity parameter, more than 50% was observed. It is because of the resolution effects. So for more details of the resolution effects, if interested, can go through this paper. Now, key contribution on the first part. So this present research successfully attempted to show that ultra low cost and sustainable Foldscope approach can be used for imaging of the sand particles, and shape parameters can be determined. Thus, the economic barriers in determining the particle shapes can be removed. Next, we have seen that for poorly graded sands, only 80 number of particles should be adequate for representative results. So the shape parameters we determined in this first section were used for studying the or investigating the influence of particle shape of dynamic shell properties, which comes to the next section. So this second part covers the influences of particle shape on shear modulus. Now we know that in the dynamic properties, the shear modulus G and damping properties D are the two most indispensable input parameters which are required to analyze all swell vibration problems. Now, in the laboratory, these dynamic swell properties, which is G or D, we can measure using resonant column and cyclic traction test. Now, for resonant column, test is mainly used for this range of strain level, which is 10 to minus 5 to 4 into 10 to minus 2. This is for resonant column test, and dynamic cyclic traction test is used for the medium to large strain levels. Now, in our research, we will be only discussing about a small strain level, which is resonant column test. So, the resonant column test is the most commonly used laboratory for measuring shear modulus and damping ratio at low to medium strains. So, we have used in GCTS fixed screen resonant column test. You can see here. This is the resonant column apparatus available at ISC. Now, what we do is this, this is fixed at the base and free to rotate at the top. So once you apply the torque or displacement, it will rotate here. Then the displacements it will provide. Then based on that number of frequencies range we apply. Then finally we get a shear velocity. Once we get a shear velocity, using this relationship Gmax equal to density into shear velocity, we can find out the shear modulus value for that. And for damping ratio, we can find out using the two methods, which I am skipping here. So using SSB, which stands for standard steady state vibration method or half power damping method, and FPD stands for free vibration decay method or logarithmic decrement method. So these two methods are used for damping calculations. But today we are mainly showing about the shear modulus results. So for sample preparation, again I can skip this. Only thing is that cylindrical mold you have to use for dynamic testing for finding out the shear modulus damping. Cylindrical mode of 50 by 100 mm can be used, and right damping method is used for sample preparation. Now, this is the results. So, figure A to C, leftmost part A, B, C is shown for the shear modulus part. Then figure this A, B, C, D is shown for the G by Gmax or normalized modulus reduction part. So, why this is? Because this is the main curve which are used for design analysis. If you have a structure and if you want to see the response to it, vibrations or dynamic analysis if you want to do, or site response analysis if you want to do, then this is the curve you have to use, G by Gmax. Anyway, so in our case, you can see Gmax value, then regularity. Okay, regularity is the average of that circularity and roundness value. What average of that is circularity. So we can see that with the increase of circularity value, your Gmax is increasing. Same for different electric density we did 30%, 60%, and 80% electric density. So with the increase in regularity value or increasing your or changing in shape parameter, you can say Gmax value or shear modulus value is changing. The same goes with this normalized shear modulus. So if you see the result here, this one I have just kept, which is seed and it is very popular curve in dynamic analysis, which was given in 1970. We are still using it in India. So if you see, with the increase in regularity value, start on A, B, C, D. If you see this data above this can increase upper one part. Now with the increase in that little bit of downward or leftward it has pushed. Again here it has come to this level. Then after that it has come to this level, leftward. That is with the increase in regularity values or particle shape changes, this shear modulus is changing or G by G max is changing. So this should be considered in the analysis for design purpose. Okay, so I have come to the these are the references. 2-3 more slides. Before concluding, I would like to take a moment to express my heartfelt appreciations to several individuals who have played a pivotal role for the success of this research. Firstly, I am grateful to my PhD supervisor, Professor Kunjari of ISC, for his unwavering support and guidance throughout my doctoral studies, particularly in carrying out the Foldscope work which we have just shown. Also, I would like to extend my gratitude to my postdoctoral mentors at IIT Bombay, Professor Pinam and Professor Deepankar Chaudhary of Civil Engineering Department for valuable support and guidance. I would like to acknowledge the presence of Professor Pinam here today at the conference. Thank you, Professor Pinam, for joining us. Lastly, thanks to our research group at IIT Bombay. Now, in conclusion, the key takeaways. I would like to express my sincere gratitude to all of you for your kind attention and active participations during this presentation. So, the International Conference on Interdisciplinary Approach and Civil Engineering for Sustainable Development has provided a remarkable platform for knowledge exchange. So our research on the low-cost sustainable full-scope approach for particle shape analysis of geomaterials and its effect on dynamic shear modulus has demonstrated the immense potential of Foldscope. So it has the capacity to revolutionize the soil classification guidelines. And I would encourage and request to all, if possible, to explore a Foldscope in your research and practice. And it has the power to drive advancement in sustainable civil engineering. Let us continue to collaborate and prioritize innovation for a sustainable future. Once again, I extend my heartfelt appreciations to our organizers, fellow researchers, and esteemed attendees for their contributions to the conference. Together we can shape a more sustainable and resilient world. So recently this work has got many attention. Thank you, and I wish you all in your continued success in your endeavors.
Thank you, sir. It was very informative session. So I request gathering to ask any questions if you have.
BTech can actually, all if you want to do some projects, all BTech, you can actually have a look of this because it's very. You don't need much more money for this. You just have you just need some particle shape or samples. Then using that, where is that Foldscope? Okay, yeah. Using this, you can easily actually do a lot of things. Okay, this is a very simple, sustainable. Since this is the conference based on sustainability, so you can use this. How you can use? Because you can simply put the particles images here. I mean, soil particle samples here. Then just fixing this on it, and you can take the pictures of that. Fine. So you can do projects, very good projects on this. So it will be more beneficial for painting particularly. You can.
We are humbled by the presence of Dr. Kunjari sir in the IACESD to 2023, and thank you for sparing your time to share your key message amongst us. Now I request Kempraju sir to felicitate Kunjari sir and Pinam Earing ma'am on behalf of Jyoti Institute of Technology, Bengaluru. State Pinom Earring, ma'am. I request Lata ma'am also to felicitate. Thank you, ma'am. Thank you, sir. We are sure that audience have found these sessions very valuable and informative. Thank you, Kunjari, sir. We are humbled by your response and thank you for all the active participation.